The Formed Book Club. Catholic book lovers unpacking good books, chapter by chapter.
Welcome to the Formed Book Club. We continue to discuss science at the Doorstep of God by Father Robert Spitzer, Society of Jesus. And Joseph Pearce suggested, and of course he always follows suggestions, at the end of our last session, that I reread these questions on page 38, chapter 1, does science point to a beginning of our universe? 3 central questions. Was the Big Bang the beginning of our universe? And the answer to that scientifically seems to be yes, of the universe that we know we can observe. 2, does our universe exhaust the whole of physical reality? Or is there some dimension of physical reality beyond our universe? That's a question we can ask. And number 3, if physical reality does extend beyond our universe, must have a beginning. But in the interregnum here between the 2 sessions, the intercessionum, I guess, we were discussing this fact that it seems like scientists will try any possible explanation to avoid a supernatural one. On the other hand, I can see that as a scientist, as part of their job is to see if they can find a natural cause for things. And so
that's true.
They were going to try and look at all the possible options. And the good thing about Father Spitzer, he looks at all the different options they've come up with, no matter how bizarre they are, like these Bozeman brains,
Right.
Or infinite multiverses.
Yeah, I mean, I agree with you, Father. You're completely correct. This is the modus operandi within which they are confined and constrained by their discipline. But when they then start, in order to try to keep within those constraints, to start becoming science fiction authors, because there's science fiction. That was, what if this true? Let's see how is this going to play itself out. 300 years from now, if this understanding is true, right? That's all great fun, and it might even teach us things about on all sorts of levels. But it's not science. Right, so at some point, these people become, in order to stay within the parameters of their modus operandi, they become science fiction authors, and at that point, they are no longer scientists. They're no longer behaving scientifically.
Also, we'll get to this as we continue here. This idea of multiverses. There's one. I haven't seen it yet in the book. It may be or may not be later on. But there's one idea of multiverses where they were there from the beginning. We're just one bubble in all these multiple universes. But there's another idea that it has to do with quantum mechanics, where the result of any reaction is statistically random. We don't know what happened. Some scientists have said, well, actually, at every moment where there's an event takes place, they all happen. I mean, quantum mechanics will tell you that an electron could be anywhere, but when you measure it, it's some particular place. But that's because in some other universe, as you made that measurement, you divided the universe. There's another universe where it wasn't at that place,
Oh my goodness.
Well, yeah.
Is that bilocation? I mean, what is that?
I tell you what it is. It's metaphysics. It's not physics. That's what it is.
Well, what is bad metaphysics? Because the idea of being, you can't have more being. You double your being just because you made a choice. I mean, it's very bizarre. But even very brilliant science, and believe me, I've spent some time studying quantum mechanics and way beyond me, and those who understand it clearly are intelligent, people understand these formula that they come up with. But they also then, humanly speaking, or philosophically speaking, they come up with these bizarre things because the scientists don't investigate being, they investigate how beings relate to each other. And so somehow when they focus all their intelligence on how things relate, how beings relate, they lose the sense of being, what being means, and how you can't simply multiply beings for your theory. You can't get more out of less. You can't get something out of nothing. Anyway, I'm wandering here, but let's go on. Where are we?
We're on page 38, Father, and I don't know whether if we want to. It depends how how to put this, how we want to follow the text as it's going, or whether we just want to give overviews. But if we want to follow the text, then obviously after that he gives the 5 variants of how those 3 questions are answered, and then and then from there. But I don't know if we want to just
let's list them there, page 39.
Yeah.
And then we can simply say that in the following pages, he gives reasons based on science whose authors' names he mentions, but we don't know them. And he claims that they have been refuted by science, and I'm willing to take his word for it, So the question is, are there other material universes beyond ours? Number one, the finite multiverse hypothesis, namely, we're one universe among a finite number of others that we haven't observed, but must be the same kind of dimension of reality that ours is. 2, the infinite multiverse hypothesis, that there's an infinite number of these physical universes. 3, the bouncing universe hypothesis, we talked about that it's our universe, but it's not just expanding, it's going to contract again. 4, the higher dimensional space universe hypothesis, which is completely bizarre. We'll see, where they say, the universe is really only mathematics,
Oh, yeah.
It's not physical. And therefore, that's the origin, the mathematics. Well, you have to have a mind on mathematics, you know what I mean? As Father Spitzer points out. And finally, the pre-Big Bang eternally static hypothesis that it's not expanding, the universe is simply in a stable, static state. So those are the 5 hypotheses. And he says below that all of these hypotheses extend our view of physical reality beyond our observable universe. That is to say, it's totally speculation.
Right.
And he says they're all completely hypothetical and lie beyond our current capacity to observe. But he can scientifically show that they lead to contradictions.
So in other words, because these are not scientific in the strict sense of the word, they are mythic and philosophical. You can't test them scientifically, but you can test them philosophically, and that's what he does. He shows that they are contradicting themselves, and they're logical fallacies, that these things cannot be true on a pure use of philosophical reason, philosophically applied.
Well, and that there's no observable data to prove that they're true. So it's the absence of a proof, really.
Oh, it's also the absence of science, because they can't use the scientific method
to
prove whether it's true or not. Right.
Right? Are we right about that?
You are, because remember he talks about the idea of science requires falsibility.
Right.
Falsifiability. If you have a thesis or a hypothesis you're trying to test, if there's no way of proving it false, then it's useless in science because you can't do any experiments on it.
So Father, I've got page 45 as just a way of maybe giving his conclusion.
Go ahead.
His discussion. So that the final one is the penultimate paragraph on page 45 before the next section. If expanding universes, finite inflationary multiverses, higher dimensional space, for example, string universes and bouncing universes, all require a beginning, and the infinite multiverse is incompatible with our observable universe and entails absurdities, then scientific evidence is pointing to a beginning, not only of our universe, but also multiverses, string universes, bouncing universes, and other expanding inflationary possibilities. And so the point is, he doesn't say these are all nonsense because they're just ideas, they're not even scientific. He does say, well, even all of these except the one which we can show to be a logical fallacy and absurdity, except for the one that we can show to be false. All the rest, which we can't prove or disprove, all require a beginning, right? So all of these, irrespective of whether they're fantasies or not, require an ultimate first cause, right? And then, in other words, science is pointing to a beginning of physical reality itself. If no physically realistic exception can be found to the BVG theorem and the high unlikeliness of an infinite multiverse, it would make an ultimate beginning of physical reality highly likely. So at the end of it all, he takes all these things and he doesn't even say that these are silly, and I think some of them probably are, right? He says, well, anyway, irrespective, they require a beginning. They require a first cause. God.
Yeah, and again, he's speaking as a scientist, saying that scientifically, all these hypotheses lead to scientific contradictions or observable contradictions. Nevertheless, that doesn't prove they're wrong. It says it would make an open beginning of this way highly unlikely, So, again, speaking as a scientist, he's saying that that's as far as we can go.
Makes it highly likely.
Highly likely.
Sorry. Would make an ultimate beginning of physical reality highly likely.
Right.
Yes.
So
again, I'll keep using the sort of term that reminds me of St. John Henry's Grammar of Assent, which Father Spitzer has cited. Beyond all reasonable doubt. In other words, what's used in the court of law, if you can find someone guilty or innocent, you have to come to a conclusion beyond all reasonable doubt. What he's suggesting here is, there's a first cause to the physical cosmos beyond all reasonable doubt. I see on the section of entropy, Father. Do you want to take it?
That's fine. We've discussed it already.
You explained entropy in quite a bit.
Maybe we don't need to.
Well, maybe we want to go to sum up for us. So given entropy and given the likelihood that the universe is uniform and rational, not that it has a mind of its own, but that it could be rationally understood, intelligible, that's the better word. Given that those things, then the law of entropy also points to the necessity of a beginning.
That's right.
Right? So he's just going at the, this is the foundation he's building, that all of our understanding of science up to this date point to a beginning.
Yeah.
And entropy is another one of those things. Because Father explained it pretty thoroughly in our last session.
He did. So I agree. We can move on to section 4. But can I just, by way of continue the conversation we've been having, go right at the top of page 50 there, towards the other section, which is where he basically summarizes very charitably and very, rationally. Though physicists are still hypothesizing new scenarios to elude a beginning of the universe from entropy, they are becoming more and more fantastic and further removed from the domain of observable evidence and the discipline of physics. Now, what he's really saying there is these people have become completely unscientific. They're not behaving like scientists.
Mm-hmm. So then the next section, the implications of a beginning. What are the implications of a beginning? Did you have things you wanted to?
Well, I that first quote one at the beginning there I like when these authorities, right? These are proven scientists, Nobel Prize winners, what have you. that they say something I can understand. That's why I highlighted it. When I get mathematical theorems above my head, I have nothing to say. But right at the beginning, Alexander Vilenkin, one of the physicists behind the BVG proof, this is his quote. It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. I mean, perfect, succinct and perfect, right? From a scientist, not from me.
Right. And scientists, of course, can disagree.
Mm-hmm.
But the good thing about having a book where it's printed is that people who disagree can express a disagreement. We'll see. I haven't heard any yet, but we'll see how many scientists might read this book and disagree. But this fellow apparently has real stature as a scientist. So,
but Father Spitzer's philosophical debunking of Stephen Hawking's nonsense on page 52 is brilliant. I don't know if you want to discuss that. So the quote from Stephen Hawking at the bottom of page 51 is as follows. Because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. Right? Now, this is Stephen Hawking, who has a great deal of gravitas, people take him seriously. And the whole of the rest of the page here is Father Spitzer is brilliant in showing how this. Can we read it? Would you mind? Can we read this?
sure. But where'd the law of gravity come from?
Well,
Where
that's not.
does the law exist except in the mind?
Well, that's exactly what he says here, but brilliantly. So Hawking's begins with top of page 52. There is a law such as gravity. And then he says, normally the word is means exists. Does Hawking mean that gravity exists? If so, then he's not talking about the universe coming from nothing, because he's implying that it comes from an existing law such as gravity. So either he is equivocating, using the term nothing with two different meanings in the same argument, which is a fallacy, or he really believes that a law such as gravity is literally nothing. This is pure logic. It's wonderful. However, if the law of gravity were really nothing, then it would have the effect of only nothing, which is no effect at all. Whatever way we look at it, Hawking's assertion here is either equivocal, self-contradictory, or just plain nonsense. It is best, therefore, to stand by the age-old philosophical adage that nothing is nothing, and from nothing, nothing comes. Next paragraph. So what must we do to treat nothing as nothing? This requires not putting any content into nothing, such as continuality, dimensionality, or orientability, as might be found in the spatial field. And then skip a sentence or two. Any attempt to equate nothing with an existing physical or transphysical condition argues the most fundamental of contradictions, that nothing is really something, or that something is really nothing. So let us all agree to let nothing be nothing. And then, I mean, it's brilliant. I mean, he really shows that Hawking is talking nonsense there.
Right.
How far are we going to go to try to prove atheism? It's absurd.
Right.
And even Hawking himself realized that. He died a believer.
Yeah, you told me that, Father. Could you expand? Because
I don't know much more about it, except that our good friend Elias Kahn, who was a friend of Hawking, and who actually at Hawking's advice or suggestion began his quantum computing company called Cambridge Quantum Computing, was close to him. And Elias himself was a very devout Catholic. There's a moratorium on writing about this for I don't know how long.
Yeah.
But Elias told me that's what happened, so I believe it.
Well, Hawking would teach at Caltech occasionally down in Pasadena, where we have relatives and we would sometimes go for holidays and so on. And I saw Stephen Hawking coming out of a Catholic Easter Sunday Mass. So,
Wow.
yeah.
Well, it's also interesting in this, actually, a bit further on, and this is, I mean, someone needs to write this, obviously, moratorium, but.
Yeah, it's embargoed for some reason for some time, and I
Yeah.
don't understand that, but I saw it with my own eyes, the man coming out.
This source, so I'm looking here, trying to get my mind around this. This is 2012, this book was published, where he said this, right? But later on, a few pages further on, next chapter maybe, something he wrote in 2018 basically contradicts what he says there.
Yeah.
He's basically saying that these new discoveries prove that whether we like it or not, there's a beginning.
I noticed that too, Joseph, that in later writings, quoted later in the book, Hawking is changing his mind about.
Right, so right at the end, yeah, he's contradicting himself, what he says.
Well, I wouldn't say contradicting. Let's give him credit for changing his mind when he finds more evidence.
Yes,
you know?
yes.
But when you change your mind, Father, you contradict your previous opinion. I mean,
well, you're not contradicting it. You are.
I'm very happy. Father, I'm very happy to contradict my old self.
Okay. I'm going to contradict your present self.
No, just don't try to contradict my future self, okay?
Let's go to chapter 2. Does fine-tuning for life point to transcendentality? So what is fine-tuning? We talked about expanding universe. We talked about entropy. Lead to that. He talks about these free parameters, which basically means what is the constant, what is the mathematical number that we have for these things. And he's going to show that in so many instances that the particular parameter that applies to a certain element or atom or function, if it was a little bit more, a little bit less, would have made it impossible for stars to form or
life forms,
whatever. Yeah. So let's go into that. Anybody want to?
Well, yeah. I like to quote authorities here, and Sir Fred Hoyle, right at the beginning of this introduction to chapter 2, who was the former director of astronomy at Cambridge University and father of the theory of stellar nucleosynthesis, was for decades an adamant atheist. After he discovered the need for exceedingly precise fine-tuning in the resonance levels of oxygen, carbon, helium, and beryllium, needed for carbon bonding and carbon abundance, and ultimately life, of course, his atheism was shaken to the core. Upon considering the options for how such precise fine-tuning might occur, he concluded as follows, and this is a quote from him, one of the most famous, obviously, physicists of the 20th century. Would you not say to yourself, some super calculating intellect must have designed the properties of the carbon atom? Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. So, Spitzer, give him absolute credit, goes on to say, well, people will question that. But the point is, we do have one of the major physicists of the 20th century, one of the most famous. Even I'd heard of him, and I'm not a history of science person. That he was an atheist, and through his study of physics, came to the conclusion there has to be what he calls a super calculating intellect, which seems to me a rather unpoetic name for God, but nonetheless, it's a very scientific name for him, perhaps.
And then humorously talks about the super intellect monkeying with the universe.
Yeah, that is good. Yeah,
that's really rich. I like it.
But again, you have to admire him. Just as some say that all roads lead to Rome, that all scientific evidence leads to God, and he was open enough to follow the evidence until he realized, wait a minute, you can't explain. It's unbelievable the coincidence which would have to have happened, trillions upon trillions of opportunities to come up with what we actually have. It also reminds us, we'll see in the chapter, how we've won the lottery in a sense. I mean, the chances of all these things being the way they are so minuscule that we say, hey, we won. They're here.
In actual fact, I mean, what I love, Father, he shows that it's much, much, much beyond winning the lottery. I mean, winning the lottery is possible by way of chance.
That's right.
By definition. But this is impossible through chance. This is much, much more unlikely than winning the lottery.
Well, I often would ask students this question. You can weigh the air, what do you think if you weighed a cubic foot of dry air and you weighed a cubic foot of water vapor, which would weigh less? And of course, they all say dry air would weigh less, right? It seems intuitive, right?
Mm-hmm.
But as a matter of fact, a water vapor is lighter than air.
That's right. That's why we have clouds.
Exactly. If it weren't that case, then we wouldn't have clouds, we wouldn't have rain.
Mm-hmm.
So water has this amazing property that as a liquid, it's very heavy. When it evaporates, it's H2O, that's two hydrogens, one atomic unit, and one oxygen with 16. So that's 18. Whereas air, oxygen molecules are O2, which is 32. So a molecule of oxygen actually weighs more than a molecule of water, vapor. So that's one characteristic of water, without which we would not be alive. There's another characteristic. When you freeze something, it contracts. When you have molten iron, it cools down, it's less. When you have molten wax and it melts down, it's less. With water, when you freeze it, it expands. And that's why ice floats, because ice is lighter than water. But if ice didn't float, then when it came being cold, all the rivers would freeze solid. Whereas now, when they freeze, the top might freeze, but the water still floats underneath it. But if water contracted when it froze, like every other element does, molecule does, then you'd have it freezing the bottom up, and then you'd have no river. We'd have no river either. So isn't this weird?
Wow. Well, that's really
lighter than air when it evaporates, but also lighter than water when it,
Yeah, I'm a few days away from my 63rd birthday, Father, and I'd never even thought about this before. So thank you for this epiphany moment. So basically, that when H2O is gas, it's lighter than H2O is liquid. But when H2O is solid, it's also lighter than H2O as liquid.
When H2O is gas, it's lighter than oxygen is a liquid. Air. Air is a gas. When H2O is a gas, it's lighter than anything else. Than oxygen or nitrogen.
Right. Right. But when that H2O, which in its usual form is liquid, below a certain temperature, it freezes. You say that it expands, but most other things contract.
Yes.
They get colder.
Yeah.
Most other things are all other things. I'm sorry. You've hit
I
an epiphany moment, so I have to ask questions.
But because you can understand, normally when the molecules are moving, it's a liquid, and as you freeze it, they don't move as much, and so there's a lot less space for them to move, and so it contracts. But water's different. You freeze it, and it gets bigger.
And so what these examples, Father Spitzer's asking the question, does fine-tuning for life point to intelligence, meaning intelligence behind the universe? Because, and this is just one small example, water. There are just so many examples of the conditions for life on Earth that they could have happened randomly is just so implausible.
I mean, later in this chapter, we don't have time to talk about it now, he gives these wonderful, I mean,
It
it's
gives
fascinating.
examples, yeah.
Yeah, wonderful examples. But again, I just we're at the 30 minutes, Father. I'm the timekeeper here.
Are we really? I don't think we are.
Time flies
Oh, we
when
are?
you're enjoying yourself.
But I love his conclusion. Maybe we could just quickly go to his conclusion
Whereabouts?
on page 58, and it goes over to 59
Oh,
because
okay,
then
because
he explains also why this is an abductive argument, because he says, in conclusion, our universe has a paradox inscribed within itself. The occurrence of multiple, exceedingly improbable, life-permitting values of free parameters with an exceedingly large volume of really possible life-prohibiting values of those parameters. Okay, and then he goes on to say, on top 59, discovering the correct explanation for universal fine-tuning cannot be accomplished through deductive argument, because we do not have a set of universal principles from which our contingent facts can be derived. Furthermore, we cannot use inductive method to move from repeated particular observations to the supposition of general laws underlying this invariant repetition. Nevertheless, we can make use of what is called an abductive argument, which, as shown in the previous chapter, elucidates and evaluates potential explanations to determine which explanation is simplest and most likely. Though abductive arguments are not as probative and definitive as deductive arguments, they can bring us closer to the truth by eliminating flawed and weaker explanations.
Yes, and so let's conclude with this thought that he brings up several times. He refers to St. John Henry Newman and his idea of convergent proof, where you have many arguments or sets of evidence which point in a certain direction, coming from different angles, and that makes it more and more likely that what it's pointing to is true. And so, like with these scientific views, we can't prove God scientifically, but we can point to these things for which God is the best explanation we can think of right now.
Yeah, and again, the process being that his absence becomes an absurdity. So you can again, if you prove beyond all reasonable doubt, his absence becomes an absurdity.
And now, the reason you have to ask yourself, God, why have you chosen to be hidden in this way? Why have you chosen to be beyond our ability to prove or disprove? There's something about the hiddenness of God that draws forth us in faith. And
GK, the whole Man of a Thursday, God is playing hide and seek. It's delightful.
Yes.
I was just thinking this morning as I was baking my sourdough bread and sitting in my office, looking across the table, I said, if Jesus were here next to me, well, how would I act? He had to hide himself when he came. Otherwise, we'd all be kneeling down and, we couldn't talk to him. He had to hide himself as a divinity in order for him to be able to interact with us as another human being.
Yes.
Father, till we have faces.
Yes.
Yes. All right. See you all next session, everybody. God bless you.
If you enjoyed this discussion, please help spread the word about the Forum Book Club by subscribing to the podcast and writing a review. You can sign up for weekly updates at forumedbookclub.ignatius.com.